Hi, and welcome to Chapter 6. In Chapter 6, we're going to start talking about networking operating systems and the different ways that they communicate. Let's get started. So to look at our roadmap, you'll see that we finished our section on media, and now we're going to start working on operating systems. We're going to cover basic networking operating systems in this chapter, then talk about some specific ones. We're going to do Microsoft's network operating systems and Linux, and then talk about a little bit about servers before we move on. So hopefully that helps you to understand where you are in the course. To understand network protocols, you kind of need to step back for a minute and look at how network protocols have changed over the years. So way back at the beginning, 1,000 years ago, no, back in the 50s, 60s, back at when the Department of Defense started building their first networks. Network protocols were Unix-based. They were TCP/IP, and we used the TCP/IP protocols at that level. There was the Department of Defense, couple of universities, not even all of them, some of the universities, but in general, the public had no access to this. This was a very close-knit group of people. We didn't have a huge amount of security issues, and everything was done with TCP/IP. Over time, different companies decided they wanted to create their own proprietary protocols. So you had Microsoft and Apple and Novell that came up with their own versions of protocols to be able to communicate across the network. So with Novell, they came up with IPX/SPX, so that was their proprietary protocol. Microsoft had NetBIOS, and Apple had AppleTalk. None of these were TCP/IP. They were all just a little bit different, and none of them could really talk to each other in the sense that we can today. It caused a lot of issues, and it caused some trouble with just being able to get information. If I have a Microsoft and you have an Apple computer, how do we talk together? Yeah, we just can't. So over the internet, you couldn't do networking protocols if you were not all in the same proprietary protocol system, which caused a lot of people to decide, I'm going to be an Apple shop, I'm going to be a Microsoft shop, I'm going to be a Novell shop, and these are going to be the places, and we're going to have everything be networked on that protocol. Obviously, over time, especially as the internet grew, this was not going to cut it. So they ended up translating their proprietaries into TCP/IP. What's funny is the proprietary protocols are still entirely used. They've just added another layer that takes the protocol and converts it into TCP/IP so it can be run across the network. So if I have a Microsoft machine, I'm still using my proprietary protocols, and then I'm converting into TCP/IP, and then it's going across the internet, and then it will unconvert or essentially go back to whatever protocol you need at your end. So understanding that TCP/IP was the first way, and then the big conglomerates or the big companies decided to make their own versions. And finally, we all accepted that TCP/IP was the base. Everything needed to be in TCP/IP eventually, but you were welcome to have your proprietary protocol up on the top part, and then just translate it into TCP/IP for transmission over the internet. So some common network OS traits. So we need to have an operating system on our network, and we need to be able to understand what those do. Currently, you can use a Linux machine, you can use a Windows machine, a Macintosh machine, these kind of things for your operating systems, and those are fine. Novell kind of went by the wayside. Every type of OS is going to have some version of logging in. Obviously, you need to control access to your server. You need to control access to your operating system and your network. They usually will have some version of a GUI, so some sort of a user interface that is going to allow you to make some changes, and of course, some file management. They also usually are going to have some sort of a command prompt or a shell. Depending on which OS you pick, all of these are going to be a little different. As you know, even with regular operating systems, Windows, Mac, and Linux are all different. Same kind of thing with their network OS. They're all just a little bit different, but they're all very similar to what you would expect from that company. So if you're looking at a Windows 2016 server OS, it's going to look similar to a Windows 10. It's going to have some of the similar traits because they're made by the same company. A couple of examples of some features that it's going to have. Obviously, a network OS has got to communicate with the internet. So we have to have some version of a TCP/IP protocol going in there. They're going to share resources. They're going to have some sort of login, like I said, some security. They may have some versions of services like your web or your email, FTPs to file transfer things across. Obviously, storage, troubleshooting, some diagnostics, some device management, that kind of thing. And then at the bottom, obviously, your interface. Again, there are some network OSs that don't have a GUI. They don't have a graphical interface. Everything is done by command line, and that's fine. There's no problem with that. It's still a way to interface from the user to the OS and back. So these are just basic OS traits. It shouldn't be that confusing because they're like any operating system that you have anyway, pretty much covering the same concepts. Okay, at this point, we're going to start delving into our OSI model layer 2. This is our data link layer. So this is where our hardware protocols exist. So when we're talking about our hardware protocols, this is going to be in the data link layer, the one that has the two different versions, the MAC and the logical link control, the LLC. So we have the two layers in that OSI model. Okay, again, remember layer 2. Always go from the bottom up. Layer 1 is physical. That's where your cable is. That's where your media is. And then we move our way up. Of the two that are inside of our DLL layer, our logical link control will communicate up and our media access control communicates down. So the little image here with the arrows going up and down, inside of your link layer, try to think of it as, are you talking to the thing above you or are you talking to the thing below you? In this situation, the logical link control receives its data and it passes it up to the network layer, up to the transport, and all the way up to the application level. So the logical link control goes up, whereas the media access control is framing or placing data on the media. So it's going down. It's going down to the physical layer. By the way, do not confuse your MAC address, which is still media access control, by the way, your MAC address with the MAC layer of the OSI model. Obviously, those are two different things. Your MAC address is a specific location of your device. MAC addresses are assigned to your NIC, your network interface card, or any device that is attached to the network, and it's a 6-byte number, a hexadecimal number. Your MAC layer is part of the OSI model DLL layer. Two completely different things. Yes, they have the exact same acronym. I know, it can get frustrating. But if you think of visually, when you're looking at your OSI model with physical at the bottom and application at the top, the DLL layer pops right in there and the MAC part of it goes down and the LLC goes up. So you can kind of get that visual in your head. When you think of it as, are you communicating up to my network operating system or am I communicating down to my media? It might help you to remember what each of the different layers is doing rather than just trying to memorize words from a textbook. Understand the media access control is communicating down with the media. It needs to talk to the media. It needs to frame things and put them on the media. The logical link control goes up to your operating system. Okay, so those are your two there. The most common hardware protocol that we use now is called Ethernet. It's at the second layer, so it's at the DLL layer. So when we talk about our Ethernet 2, it's always at the second layer of our OSI model. At the Ethernet level, we use collision avoidance as opposed to collision detection. We talked about that when we were talking about our media with our cabling or our wireless. Which one did we use? The CSMA collision avoidance or collision detection? In the case of the Ethernet, we use collision avoidance. So if a collision is detected and avoided, it essentially gets the notification saying, hey, there was a collision. We didn't go anywhere. We avoided it. And it's like, cool, okay, we'll resend the packet. That's what the Ethernet layer will do for its collision avoidance. It's going to resend that packet automatically because it avoided the collision. Nothing got sent. And it knows that because it has this collision avoidance detection in its interface. That's how it designs. One little thing on collision detection versus collision avoidance. Ethernet used to use collision detection, and just over time it has advanced and evolved into the collision avoidance. So there are some Ethernet protocols prior to recent that did use collision detection. If you've used Ethernet and you're like, no, I remember it uses collision detection, you're right, it did. Now it generally will use a collision avoidance. So a broadcast storm is when there are so many collisions that those collisions keep resending the same packets, which cause more collisions, which keep sending resending the packets, and then everything is just a resent packet and nothing gets done. There are so many packets being resent that there's still no place for anything to go, and everything just causes this huge traffic jam and nothing's moving. With a broadcast storm like this, your network goes down. Nothing can move. Everything is filled with resends of the same packets, and everybody's confused. The only way to stop a broadcast storm, shut down your network. You have to shut down everything, restart your network, and clear everything out. It's just like if you get one of those viruses on your computer that thinks that it's running constantly and your entire computer crashes, the only thing you can do is shut it off. So shut the whole network down and then bring it back up, and hopefully all of that will get cleared out of the cache, and then things will start to run as they normally do. So those are called broadcast storms, and kind of like blizzards in Montana, you just don't want to be out in them. And if there is one, just stay home, start over, turn everything back on again, and wait for it to just pass. Okay, your collision domain. When we are looking at our network, we can section the network where collisions occur. So if I have 3 computers hooked up to a switch, which is then hooked up to the rest of it, and in this section, these 3 computers just seem to keep hitting each other. They keep sending at the same time. There's something about the way these users work, or something that is causing a collision to occur in this segment. We call that segment now a collision domain, because that domain, that area, is now filled with collisions, and we have to clean it up. The way we can solve a collision domain is that we can section parts of the network out to pull out the things that are bumping up against each other. When we section part of our network, we call it segmenting. One really important thing about segmenting, you can use a switch to segment. Switches can segment. You can use a router to segment. Routers can also segment. They can also break up the computer or the network traffic into different segments and do that. Hubs do not segment. Hubs are not segmenters. They do not break things up. So you never want to use a hub to segment your segment your network. You want to use either a switch or a router. So remember that hubs do not segment. So again, Ethernet layer inside the DLL layer at the second level. It's the hardware protocol that is going to handle collisions and keeping track of data going in and out. So in this layer, remember, you've got your LLC and your MAC, talking up, talking down. Lower level protocols such as the Ethernet and token ring all work at this data link layer. By the way, quick note on token ring and ArcNet. Token ring and ArcNet are what we call older technologies. That doesn't mean that they don't currently exist. They do. It's just they're not currently on the Network Plus test, and I'm not going to spend a huge amount of time on them. So they're both protocols. They're in the book if you want to go read a little bit more about them, but I'm not going to waste your time doing a huge description on either of them. So the section we just did was on the data link layer at the second layer. Everything above that we call our networking protocols, TCP, IP. So TCP IP is not a singular protocol. First off, it's TCP is one protocol, IP is another protocol, UDP is another protocol, and it includes kind of the whole suite of TCP IP protocols. There's a lot of them in here. There are so many high-level functionalities that exist for one protocol to contain it all. So in the case of TCP, we have HTTP for hypertext. We have FTP for file transfer. We have POP3 for internet or for email. We have SMTP, we have DNS, we have SSL. These all exist up in that 5, 6, and 7 layers. Each of those proprietary protocols also exist here. And then, of course, we have our network and our transport. So starting at the bottom, our network protocols are going to be our IP protocols. This is 3. This is layer 3. IP protocols exist at layer 3. Go up to layer 4, and you get your TCP or your UDP. These are your 2 different options for layer 4 for your transport. And then from there, we move into 5, 6, and 7. We sometimes group 5, 6, and 7 together as a singular entity because they all kind of cover the session presentation application in their protocols. So we have listed out here Microsoft's, Linux, and Apple's versions of their proprietary protocols at the 5, 6, and 7 layers. So we call them vendor specific or proprietary. Microsoft uses the SMB. So SMB stands for Server Message Block. And then they also use NetBIOS at the session level to kind of control the sessions. We talked a little bit about NetBIOS a while ago. We then have Linux that uses NFS, which is network file sharing, and a version of SMB that they called Samba. So those are in the Linux version. And then Apple uses the Apple file protocol, the NFS, which Linux uses, and the SMB, which Microsoft uses. So there's this nice little triangle between the three major networking protocols and how they talk to each other, because Apple and Microsoft both use SMB. They can talk to each other with that. If Microsoft wants to talk to Linux, it's going to use that Samba or the SMB, which are very similar, and they can talk to each other. And if Linux needs to talk to Apple, they both use NFS. If you're inside an entire Apple shop, you can use AFP, but nobody else uses it except Apple's. So those are the different ways that the different proprietary protocols can talk to each other. Worst case, they can always go down to TCP and then work their way back up. So that's how we handled proprietary. When we talk about the suite of regular TCP IP protocols or TCP protocols at the 5, 6, and 7 layer, that's where we get into that list that I talked about that's listed out here, different protocols that are not proprietary. HTTP is not proprietary. Microsoft doesn't own it. Apple doesn't own it. Google doesn't own it, amazingly. FTP, file transfer, you can use that with anything. So it's not a proprietary protocol. You can use that, or you can choose to use the proprietary one for your version. In the little graph that's over on the right-hand side, they just give a couple of examples of the original networking format. If you were in a Windows machine, you used to use a name. It could be like station 1 or station 2. It was actually words. Obviously, Linux, Unix used TCP IP, so it looks like a TCP IP address. So a 192, 168, whatever. MAC addresses would be like 212, something very small. And then NetWare would use this really long, weird hexadecimal number. Everything kind of got standardized down to the TCP IP because everybody understood it. But that was the original proprietary networking formats that these different versions would use. So at this point, we're going to talk about what we call discovery protocols. These are the protocols that are going to help the computer to find things, find other computers, to find other networks on their, or other computers on their network, other devices. We start with our basic link layer discovery protocol. And this protocol is used kind of by everybody else to advance how to do their version of connecting to other protocols. So the LLDP is kind of the base. We're going to start there. We're going to start with the vanilla ice cream, and then we're going to add a couple of other things. We'll add some chocolate chips and make it into chocolate chip ice cream. We'll add some strawberries, make it into strawberry ice cream. In this case, we're going to take link layer discovery protocol and advance that for each of the proprietaries that we want to work with. So if we take link layer as the basis, it's open source. We love our open source. It's open source so that each of the different router manufacturers can make their own, and they can make it best for their router. Underneath that, we have our LLTD, topology discovery, and this is Microsoft's network and sharing. They use two different pieces, the mapper IO and the responder. So if you go into your network and you look at the extra little pieces of your network details, under properties, you should see something that says, if you're in a Microsoft machine, you should see something that says mapper IO driver and LLDTD responder. This is the thing that figures out, are there any other computers around and do I need to talk to them? So we're just going to look around at the world and we're just going to see, hey, are there networks? Are there computers on my network? Can I see them and can I do something with them? Cisco has their own version. Their version of CDP, or Cisco Discovery Protocol, started with LLDP like everybody else, and then kind of customized it specifically for Cisco routers. So if you are in a Cisco house, like the college is, you can use the CDP, the Cisco Discovery Protocol, to be able to communicate with other Cisco devices, so the other Cisco routers. We have an LLDP MED, Media Endpoint Discovery. This is designed for the non-proprietary routers, so not Microsoft's, not Cisco's, designed for other routers and switches, and then it's also used for voice over IP and power over Ethernet devices. This is a media endpoint discovery where it took that basic LLDP and expanded upon it to be used with routers and switches specifically. So the regular base LLDP was not specific for a router and a switch. It was just a generic basis to talk to people. In this case, it was specifically designed for both routers and switches and using it over voice over IP. Underneath that, we have our link local multicast name resolution. So remember when we talked about our DNS and what happens when you can't reach your DNS and how do I figure out what things are if I don't have a DNS helping me to figure out what it is? So I want to go to Google and I type in google.com and the DNS server is down. So I don't have a DNS server. So it doesn't know how to convert google.com to 8888 or whichever version of IP address I need to go. Your LLMNR, your multicast name resolution, uses information from other computers around and the different versions that they have of their naming system to be able to serve as a DNS if the DNS is not available. In that case, if you have already gone to Google and you already know what the IP address is and your computer's just sitting there with that piece of information, and you then ask to go to Google but your DNS is down, it can use the LLMNR to be able to resolve that address and be able to get to where it needs to go. So that's how the multicast name resolution, it's able to multicast. It can send out and it says, hey, does anybody know where google.com is? And everybody can respond and go, yeah, I know, it's at 8888. And they're like, okay, cool, thank you, appreciate it. We're going to multicast to the world, to the network, and we're going to say, hey, does anybody know? And then be able to resolve our name in that case. The last one is what we call an address resolution protocol. And this is specifically resolving an IP address to a MAC address within your network. Inside your network. We're not going out to the internet at this point. We're just staying in the network. And I want to know where Cheryl's computer is. And I can use my ARP to find that. So I can go into my ARP and I can say, I'm looking for Cheryl's computer. And it can go, okay, let me look. Cheryl's computer is at 192.168.235. That's where Cheryl's computer is. And you're like, cool, thanks, appreciate that. So this is within your network as opposed to the LLMNR, which is anywhere in the internet using any type of name resolution that it can. The ARP is within your network only. So these are the different ways that we can use protocols to figure out information from around us. Who is in our network? Who is available? Who can I talk to? And can anybody share some information with me so that I can use that and move on with my day? So this is a pretty short chapter. It's kind of intense though, because trying to remember all of the protocols, what they do, what layer they're at, is really kind of an important part about this course. So you can do the review questions if you choose. Again, they're sometimes helpful for remembering vocabulary words, so on and so forth. In the study guide, there's only 4 sections. It's pretty quick, 6.1 through 6.4. Please go ahead and do the study guide. In your labs, I would like you, even if you don't have a second computer, to go ahead and try Lab 22 using Packet Tracer and Lab 23. So if you don't have a second computer that you can do, you can go ahead and use Packet Tracer. In Lab 23, steps 13 through 21 and review question 1 are specific. Otherwise, do all the rest of the questions. So you can skip 13 through 21 of the questions if you don't have a second computer to be able to do that lab. 24 and 25, go back into Wireshark using the sample files. Since we've given you a little more information into the protocols, what they do, and how they're used, hopefully the Wireshark will start making a little bit more sense now. So 24 and 25 are Wireshark specific. When you're finished with your labs, 22 through 25, yes, all 4 of them are required. At least give me a note that says, this is how I did it in Packet Tracer, but remember to fill out the in-procedure questions and the review questions at the end. Remember that StudyMate is always there. So Chapter 6 is StudyMate. And then, of course, the Chapter 6 quiz. Remember, no notes, no books. Even though I'm not busting you on it, try to do it without your notes. Go ahead and take it the first time without your notes, or with your notes if you want. Take it a second time without your notes. See how you do. It's important for you to get used to the idea of being able to do this without having that crib sheet or that cheat sheet on the corner helping you. Which protocol is which? What's my OSI model? By this point, you should be starting to feel much more comfortable with these terms. Thank you so much for watching this video on Chapter 6 on our networking transmissions. Come back next time and we will start getting into our Microsoft OS. Have a great day.